Muzzle velocity is the speed a projectile has at the moment it leaves the muzzle of the gun. The velocity of a projectile is highest at the muzzle and drops off steadily because of air resistance. Projectile speed through air depends on a number of factors such as barometric pressure, humidity, air temperature, and wind speed. In conventional guns, muzzle velocity is determined by the quality, burn speed, expansion, and quantity of the propellant, the mass of the projectile, and the length of the barrel. A slower burning propellant needs a longer barrel to burn completely, but can on the other hand use a heavier projectile. A faster burning propellant may accelerate a lighter projectile to higher speeds if the same amount of propellant is used. In a gun, the pressure resulting from the combustion process is a limiting factor on projectile velocity. A balance between propellant quality and quantity, projectile mass, and barrel length must be found if both safety and optimal performance is to be achieved. Longer barrels give the propellant force more time to work on propelling the bullet. For this reason, longer barrels generally provide higher velocities, everything else being equal. As the bullet moves down the bore, however, the propellant's gas pressure behind it diminishes. Given a long enough barrel, there would eventually be a point at which friction between the bullet and the barrel, and air resistance, would equal the force of the gas pressure behind it, and from that point, the velocity of the bullet would decrease. There is much interest in modernizing naval weaponry by using electrically driven railguns, which overcome the limitations noted above. With railguns, a constant acceleration is provided along the entire length of the device, greatly increasing the muzzle velocity. The United States Army defines different categories of muzzle velocity for different types of weapons.